All right, guys, here we go. So yesterday, we started graphing the quadratic equations from scratch. They gave you a quadratic equation, you found its vertex, you found its AOS, you created the U-shaped graph. So yesterday, I showed you guys how to graph the quadratic equation using that table. There is a shortcut to graphing a quadratic equation without using the table. So after today, you can pick what you want to do. Do you want to stay and be a table person, or do you want to use the shortcut? It's going to be your choice. There's only a specific kind of quadratic equation that I think you should all use the table for. I'll show you it on Monday, but otherwise, it's fair game. All right, so you know how when you guys graphed a straight line, y equals mx plus b, you found your y-intercept, you plotted it, and then you used your slope, your rate of change, to move from one point to the next. Well, guys, the reason your line was straight is because the rate of change was constant. It was always the same. You went up 2, right 3, up 2, right 3, and you were able to plot your points just by counting the steps. A parabola, obviously, is not a straight line. So it doesn't have a constant rate of change. It doesn't have a slope where it's going to be the same distance in between each pair of points. But it does follow a pattern. And if you want to memorize the pattern, then you're going to be able to count from one point to the next and be able to bypass the table. So the pattern that a parabola will follow, I call it the step pattern. You can call it whatever it wants. But the step pattern that this parabola will go up or down by, it depends on the a value. So a was the number in front of x squared, right? Your leading coefficient. So we already use a to find out if the parabola goes up or down. Now he's also going to be your pattern number. So he's a pretty important number that you're going to use quite a bit, all right? And then the pattern says this. From your vertex, you're going to move right or left one space at a time to the next x coordinate. So the pattern is always making you move one space right and one space left. One space right and one space left. Then you're going to move up or down following the pattern 1 times a, 3 times a, 5 times a, 7 times a, and 9 times a. So if a, your leading coefficient was 1, then 1 times 1 would be 1. 3 times 1 would be 3. 5 times 1 would be 5. And then it would be going up by the odd number pattern. 1 jump, 3 jumps, 5 jumps, and so on. But I don't want you guys getting too hooked on that, because if a is not 1, then it's really not an odd number pattern. You have to do 1 times the a value, 3 times the a value, 5 times the a value, and so on, all right? So I know the pattern sounds like, what? But I'm telling you, it will take so much time off of your graph if you use the pattern. So let's try it. So let's try number 1. First, I got to get this information, and then I'll move it up. All right. So if I hit, Darren, you should like this. This is a shortcut. All right, so if you're going to graph this quadratic equation, first of all, who is A? 1. So guys, now you know this parabola will open up or down. Up is positive, which means your pattern will be taking you up. You're going to get positive pattern numbers. It also means that if you are going to use the pattern, that's the number I'm talking about. That's A. He is who the pattern depends on. All right, B is -6, and C is 3. You still have to use the formula for your vertex. You still got to calculate your x-coordinate and whatnot. So let's get our vertex like normal. And we said the x-coordinate of our vertex will always be equal to what formula?
-b
over
by 2a.
Beautiful. Guys, I always write it down because I think that the more you write it down, the more you're going to memorize it, and you have to memorize it. I'm not giving it to you on a quiz or a test. All right, so the opposite of B will be 6 over 2 times A, which is 1. So guys, at the end of the day, what's 6 divided by 2? 3. So the x-coordinate of your vertex is definitely 3. So we know the x-coordinate is 3. Now we need the y-coordinate. So you have to plug this number in and see who comes out. So y will equal, let's plug in 3. So it'll be 3 squared. Subtract 6 times 3 and then plus 3. Type that in just how I wrote it, and it'll do the whole thing for you. Now, I tried to make it so that every number we get will fit on our graph. So nothing should be off the graph. If it's off the graph, meaning bigger than 10 or -10, you're wrong. What did we get? Somebody said it, negative 6. Okay, so now we know the y-coordinate is negative 6. So guys, let's do it. Let's start the graph. Go right to your graph, and everybody plot a vertex at 3, negative 6. I got to erase this because I had to move mine up. All right. So we're going to go right 3 and down 6. Everybody draw your AOS to help us with the symmetry. Okay, anybody know what the equation of that AOS is? X equals 3. Okay, so yesterday, I would have told you, go to your table, plug your vertex in the middle, and then pick 2 x values to his right, so 4 and 5, and plug 2 x values to his left. So I would say 2 and 1. And then you'd have to pick which numbers you want to plug in and do that. The pattern says, no, you can skip the table. The pattern says do this. Who was A in this problem? 1. So if A is 1, then we're going to go up according to the parabola, because we know this parabola is going up, by a pattern of 1A, 3A, 5A, 7A, 9A. But guys, I only make you find 4 more points. So you only need to do 1A and 3A. I don't make you find anything after that. All right, so if A is 1, guys, what's 1 times 1? 1. So that'll be the first number of jumps up that we do. What is 3 times 1? That'll be the next number of jumps that we do. All right, so everybody go to your vertex. The pattern says, from your vertex, I want you to go to the right 1 space to where the next x coordinate is. According to the pattern, we're going to jump up 1 unit first. So everybody jump up 1 unit and put a dot. That's where the next point is on your parabola. Go from your vertex to the left and jump up 1 to match it. So guys, I'm telling you right now, if you were doing the table and somebody plugged in 2, guess what number would have come out? 1. Nope. Negative 5. I swear to you, if you plugged in 2, negative 5 was coming out. If you plugged in 4, negative 5 was coming out. And I'm going to make you do that in a second. All right, now, continue with your pattern. I want everybody to start at your new dot. Don't go back to the vertex. From your new dot, I want you to go right 1 again to the next x coordinate. Now the pattern says to jump up how many this time?
3.
Jump up 3. 1, 2, 3. And then you can go left and jump up 3, or you can just match them over your axis of symmetry. And then you're done. You have your parabola. And you didn't have to plug anything in other than the x-coordinate of your vertex. So now, guys, I swear to you it works. It's crazy how a parabola really does increase by this pattern. So like I said, if you don't believe me, you probably would have plugged 2 and 1 in. When you plug 2 in, you should have gotten negative 5 out according to this parabola right now. So our parabola was this, y equals x squared minus 6x plus 3. I want everybody to plug in 2. And I want to prove to you that negative 5 really does come out. And the pattern is getting you the correct y coordinates. So plug that in. Humor me, act like you're typing buttons on a calculator. Something. All right, 4, subtract 12, plus 3. Who does your calculator say you get? Negative 5. I swear to you that that is the correct point on your parabola. The pattern does work. So in the beginning, the pattern's always like, oh, I don't know where, it's kind of a little weird. But the more you use it, you really do get better with it. And I'm telling you, it takes a lot of time off of your graph. Let's try it again. Let's try to get this into a routine. Now, after today, if you're like, Hardy, it's not for me, I'm not going to force you to use it. You do whatever you need to do. If the table is your guy, then use the table. All right. Let's look at example number 2. In this problem, in this quadratic equation, who's A? Now he's negative 1. So again, does the parabola open up or down? So now your jumps should be going in the downward motion, in direction. Your jumps should be negative numbers. So if you're going to be a pattern person, you're going to need that number. All right, B is 4 and C is 3. Everybody find your vertex. Do a little negative B over 2a and see what we get. The opposite of b over 2 times negative 1. Anybody know what's negative 4 divided by negative 2? 2. So we have a positive 2 as the x-coordinate of our vertex. All right, now let's plug it in, see who y is. Guys, remember yesterday I warned you, you are squaring x, not the negative 1 in front. So that negative sign has to stay outside of the parenthesis. Think of it as negative 1 times whoever you're squaring. So if it helps to put the negative 1 in front, please do. Because what number is this assumed to be right here? So if it helps to think of it as a negative 1, put it. Otherwise, just leave it as the negative sign. Whatever works, all right? And then we're plugging in 2. Anybody get a number? 7. It is 7. So now we know we have a vertex at 2, 7. So if you're a pattern person, your work is basically done. You got your vertex. Now you're going to count to your next points. Let me jump down here to my graph. All right, so let's plot our vertex, 2, 7. So to the right 2 and up 7. Give me a little AOS to help with the symmetry. Anybody know who the equation of that AOS is? X equals 2. And now, if you were a table person, I would advise you to put it in the middle and then pick 2 x's to the right, 3 and 4, and pick 2 x's to the left, 1 and 0, and then start plugging stuff in. Or, let's use the pattern. Who was A in this problem? Negative 1. So that's who the pattern depends on. The pattern will go up or down following 1a, 3a, 5a, and so on. I only make you use the 1a and the 3a. So guys, if a is negative 1, what's 1 times negative 1? So now you're going to go down 1 jump first. The negative means you'll be jumping in the downwards direction. All right, what is 3 times negative 1? Negative 3. So now you'll be jumping down 3 spots next. All right, so everybody go to your vertex. From your vertex, we're always going to move 1 to the right to the next x-coordinate. How many jumps down first? 1. Just 1. All right, now you can either match it on the other side of your AOS, or from your vertex, go left 1 and jump down 1. Boom. Now.
Wait, Miss Harvey?
Yes.
Wait, I'm confused how wouldn't it be negative 1 times negative 1 and be positive 1?
What do you mean? Where you're getting negative 1 times negative 1? I told you the pattern follows what number?
Oh, I'm sorry.
1a, 3a, right? And a is negative 1. So that's 1a, 3a is 1 times negative 1 and 3 times negative 1.
Yeah,
Okay? So now from your new point, we're here. Move to the right to the next x-coordinate. How many jumps this time? 3. Go down 3. There's your next point. Go left 1 from here and jump down 3. All right, let's check something out. I told you guys that your y-intercept always has what x-coordinate? 0, right? So who's the y-intercept here? 0, 3. So guys, when you plug 0 into that quadratic equation, who should come out every time? Who do we say is always going to be your y-intercept? 0 goes in. Who's coming out? C. Who's C in this problem? And who was your y-intercept? So it's working. It's getting the correct points. All right, let's try it again where A is not 1 or negative 1. Yeah. Are you okay with this, Jake?
A little bit.
Maybe see one more without an A value of 1?
Okay.
All right. All right, here we go. Let's do 3. We have a quadratic equation in standard form. Who's A? 2. So that parabola is going to open how? Up or down? Up. We know it. That means your pattern numbers are going to be positive and you'll be jumping up. B is 4. C is negative 6. Let's get our x-coordinate. The x-coordinate of our vertex will be equal to the opposite of B over 2 times A. Who's the opposite of B? Negative 4 divided by 2 times A, which is 2. Guys, what's negative 4 divided by 4?
-1.
Negative 1. So you know the x-coordinate is negative 1. Guys, if you're plugging this into your calculator, you can't just do negative 4 divided by 2 times 2. It'll do this first. Negative 4 divided by 2 is negative 2. And then negative 2 times 2 is negative 1. So please make sure you get a bottom number first or use parentheses, because otherwise it's not going to get you the right number. All right, negative 1. So now plug in negative 1 and see who your y-coordinate is. So that'll be 2 times negative 1 squared plus 4 times negative 1, and then subtract 6. Plug that in, hit enter, it does the whole thing for you. What number did you guys get? I got negative 8.
Oh.
All right, so that means negative 1, negative 8 is your vertex. So let's plot it. Left 1, down 8. Put your AOS up there to help you with your symmetry. What is the equation of our AOS? X equals negative 1, right? It's going to match the x-coordinate of our vertex. All right, so now you're either going to make a table and pick 2 x's to the right and 2 x's to the left, or you're going to use the pattern. Who's A in this problem? 2. So the pattern says we're going to go up because we know the parabola is opening up, following a pattern of 1 times A, 3 times A, 5 times A, 7 times A, and so on. Well, guys, if A is 2, what is 1 times 2? So that'll be the first number of jumps you make. So the bigger A gets, the bigger your jumps are going to be. All right, 3 times A is then 3 times 2. What's 3 times 2? That'll be the next number of jumps you make. All right, so everybody go to your vertex. To the right, 1. How many jumps first? Up 2. 1, 2. Put a dot. And then you can either match it on the other side of your AOS, or from your vertex, go left 1 and jump up 2. All right, now, from this point, I need you to go to the right 1 to the next x value. Now how many jumps up does our pattern say to do? Now we're going up 6. 1, 2, 3, 4, 5, 4. Landed on the next intercept. All right, now I'm going to match it by going to the left 1 and up 6 as well. Done. Connect your 5 dots, and you have your parabola. Guys, if I plug 0 in, who's coming out? Negative 6. So 0, negative 6 is your y-intercept. 0, 1, 2, 3, 4, 5, negative 6 is our y-intercept. It's finding the right points. All right, I'm going to do number 6 with you next. And then I'm going to have you guys do 4 and 5 on your own to practice, and then you can work on your homework after that. So everybody jump down to 6, and let's see a different A value again, and then we'll stop there. And you can finish the last 2.
My friend is working on, so I was talking about.
This is what you were talking about?
Oh my god.
Oh, you must have Mr. B and Keeney's then, maybe.
She's an author.
Oh, okay. All right. In this one, who's A?
-3.
Negative 3. Is this parabola going to open up or down? Down. So now you know your jumps are going to be negative numbers. You're going to go down from your vertex. All right, B. Whoa. Negative 30. C. Negative 67. Okay. Everybody get your vertex. The x-coordinate will be the opposite of B over 2 times A. Who's the opposite of B here?
30.
30 over 2 times A, which is negative 3. Guys, what's 2 times negative 3? Negative 6. What's 30 divided by negative 6? Close. Negative 5. So now we know I thought you said positive 5, sorry. Now we know the x-coordinate is negative 5. So everybody plug negative 5 in. Let's see what y-coordinate comes out. So it'll be negative 3 times negative 5 squared minus 30 times negative 5, and then minus 67. You're actually going to get a fairly reasonable number. It'll still fit on our graph. What do you get?
I got 8.
I got 8.
Yeah.
I got 8. -5, 8. So I need everybody to plot that. Let's go left 5 and up 8. All right, now put your AOS to help you with your symmetry. What's the equation of our AOS? X equals -5. Okay, so now you can either make a table or you can use your pattern. Guys, who is A in this problem? -3. So that's who your pattern depends on. So 1 times A, 3 times A. Well, what's 1 times -3? -3 will be the first set of jumps. What's 3 times -3? -9 will be your next set of jumps. All right, let's do it. Everybody go to your vertex. From your vertex, move 1 to the right, because you always do. You're just trying to get to the next x coordinate. At the next x coordinate, how many jumps do we make? Down 3. 1, 2, 3. Boom. Next point. All right, and I can either match him 1 space away on the other side, or I can go left 1 and jump down 3 as well. Now, from this point, let's go right again to the next x coordinate. How many jumps this time? 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. And then you can either count from here, left 1, and jump down 9, or just match him 2 spaces away on the other side. And you're done. And there is your parabola. So I want to see problems 4 and 5 done. And then when you finish those 2, you have yesterday's homework on Delta Math that is due tonight. And if you haven't done it, you can use the shortcut now. And then you have 5 more questions for today's homework that is due Sunday night. So yesterday's is due tonight. These 5 are due Sunday night. All right, thanks. So you guys do 4 and 5. I'm going to check them. Thank you.
Thank you.
Don't use a homework pass on this.
I need one. How do I use it?
No, you use homework passes on stuff that you know, and you don't need to practice. If you got to practice something, you're silly to use a homework pass
It's
on
one of
that.
these ones where it's speaking to me and I can't do it.
You've been in a really bad mood, Darian, for like 2 months now.
No.
Since Christmas. Everything puts you in a bad mood in this class now.
No.
Yes.
The last thing was easy. This is so hard.
No, it's not. You're making it hard because you're rejecting it. Oh, I can stop recording now as I'm yelling at Darian on camera.